ION-E simplifies and streamlines your in-building wireless deployment, making it a viable solution even in places where it simply didn't make sense before. This advance is possible thanks to Commscope's innovative approach, both in terms of the infrastructure itself and the personnel needed to install, configure, and maintain it. ION-E brings wireless and Ethernet architectures together into a simple, cost-effective infrastructure using 10G Cat6a cable, such as Gigaspeed Extend, and single or multi-mode fiber such as TerraSpeed and LaserSpeed. Commscope's IT cabling infrastructure is designed to work seamlessly with the ION-E solution. ION-E features a simple architecture. The Central Area Node, or CAN, provides server-level control and primary signal distribution between signal sources such as eNode Bs and ION-E Universal Access Points, or UAPs, which are fed with data and power by Cat6a cabling. Secondary distribution is handled by transport expansion nodes, or TENs, which are connected to the CAN using multi-mode or single-mode fiber. UAPs connected to the TENs extend the reach and capacity of the system. The list of ION-E hardware components is a short one. The CAN is centrally located in the telecommunications MDF closet with servers, BTS, and PBX. The TENs are housed in the telecommunications IDF closets. The infrastructure follows the same layout as a building's IT and Wi-Fi infrastructure, including the UAPs. Let's look at each in detail. ION-E's simplified design is comprised of just two 19-inch rack-mount wireless communications switch, or WCS subrack types, the 2U and 4U. Each is configurable with a selection of universal cards to support various transport options. The 8 extra card slots support additional RF donor and optical transport cards. Each card is numbered to assign a specific ID to its card. For enhanced consistency, the WCS4 uses the same slot numbering scheme as the WCS2. In both cases, the card slots are numbered from the bottom to the top of the subracks. The 4 lower left-hand slots supply power over Ethernet, or PoE, to connected devices when a copper transport card or CAT card is placed in those slots. The integrated fan module ensures that the subrack fans can be replaced quickly when necessary without system interruption. The WCS power and rectifier control connectors, which receive DC voltage from the power supply subrack, are located on the rear panel. The alarms connector provides input and output alarm contacts for external site equipment. The POI power and communications connectors support the optional ION-E point of interface subrack. The System User Interface, or SUI card, features 3 RJ45 Ethernet connectors for communications and a USB connector for transferring files. The local port provides an Ethernet connection to a local laptop for direct on-site communication with the ION-E system. LAN 1 is used to interface with other nearby WCS subracks that may be co-located to serve as a common collection point. LAN 2 is the remote access connection, which is connected to a LAN or a wireless modem for network access to the ION-E system. The RF donor, or RFD card, handles the RF connections between the WCS and the external RF source, such as an eNode B. The high-density card is capable of supporting up to 4 signal inputs per card. Each of the 4 Quick Connect QMA RF connectors have a send and receive path. The individual ports can be configured to transmit only, receive only, or transmit and receive. The LCD display provides RFD port information. The Optical Transport, or OPT card, enables fiber transmission between subracks. The card has 4 slots that support standard SFP plus plug-in optical transceiver modules, including multi-mode, single-mode, or a combination of single and multi-mode modules. The Copper Transport, or CAT card, provides data and power to Universal Access Points, or UAPs, over Cat6a cables. Each of the 4 RJ45 ports supplies 2 PoE circuits, one for the UAP and one for a second device connected to the UAP's auxiliary port. When connected to UAPs, the CAT cards must be plugged into the 4 lower left slots of the subrack to provide power to the UAP. The card's power over Ethernet LED provides visual confirmation that it is receiving voltage from the subrack to power the UAPs. Each of the ports has an LED that indicates port connection status and speed. A 1 gigabit path for Wi-Fi access points, IP cameras, or other Ethernet applications, which is cabled to a standard Ethernet switch, is available via the Auxiliary Unit Transport, or AUT card. Each AUT card has 8 RJ45 ports arranged in 2 rows. The ports in each row are directly mapped to the ports of the adjacent CAT card. This pass-through capability helps maximize the capacity of your Cat6a Gigaspeed Extend cable infrastructure. The WCS is flexible and upgradable. Additional cards can be added to the WCS by filling unused slots or adding additional WCS subracks to handle future growth. All open WCS subrack slots must be filled with blank panels to optimize airflow. The Universal Access Point, or UAP, is a compact, low-profile transmitter-receiver that provides in-building wireless coverage. The unit supports a frequency spectrum ranging from 380 to 2700 megahertz. The UAP is easy to install and manage, requiring only one Cat6a cable for both data and power. The unit's integrated antenna ensures excellent coverage without the need to install external antennas. The UAP's multicolor LED indicates the power and alarm status for the unit. The LED can also be placed into a blue flashing state with a user interface software to confirm the identity of a specific UAP. A second UAP or 1G Ethernet device, such as an IP camera, can be connected to the UAP to further simplify installation and reduce cable clutter. The red button allows you to shut down the UAP prior to disconnecting the Cat6a cables to prevent possible damage to the connectors. Installation of a UAP takes only a few minutes using common tools. Both wall and ceiling mounting options are available. The intuitive ION-E software user interface handles the distribution of the RF signals to UAPs. The status of all UAPs in the system is continuously updated and available to the operator. The simplicity of ION-E means easier deployments, reduced labor costs, and more flexible, adaptable configuration and reconfiguration. Convergence is the key, and ION-E is the solution.